All right, welcome to 1.1 example 3. We are talking about transformations. We've seen translations, which are shifts up and down, left and right. Next, we're going to look at a reflection. A reflection is a transformation or a change that flips a graph over a line. That line is called a line of reflection. So we're going to flip our graph. And you can see here our parent function in black has been flipped over the x-axis. So in this case, our x-axis is our line of reflection. And we're gonna see why this works. Okay, so it says graph y equals negative or opposite of x squared and the function's parent function. So what I'm gonna do is make a table of x values. -2, -1, 0, 1, and 2. And first we're going to graph our parent function, which is y equals x squared. All right, so given any x value, I can substitute it into the function and get an output, our y value or our f of x. So when I input a -2 into the function for x, x's are my inputs, I square that. -2 times -2 will give me +4. -1 squared, -1 times -1 would be +1. 0 squared is 0, 1 squared is 1, and 2 squared is 4. So if you look at our graph, we can see, we can prove to ourselves that this is correct. These data points here, remember these are x, y coordinate points. And when we graph them, -2, 4 is this point, -1, 1 is here, 0, 0 is here, 1, 1 is here, 2, 4 is there. All right, next we're gonna graph our new function, which is y equals the opposite of x squared. So what this gonna do is it's gonna take the opposite of all of our outputs. So when I substitute in a -2, order of operations tells me I need to square it first, then multiply it by this -1. So -2 squared, -2 times -2 is 4, and then the opposite of 4, or 4 times this -1, would be -4. So that negative in front takes the opposite of all of these outputs. So -1 squared is 1, the opposite of that is -1. 0 squared is 0, the opposite of 0 is still 0. 1 squared is 1, the opposite of that is -1. 2 squared is 4, the opposite of that is -4. All right, so these are our new data points. I have a -2, -4, a -1, -1, etc. -2, -4 is down here, -1, -1, 0, 0, 1, -1, and 2, -4. So the negative in front of the function, when I took the opposite of the function, I got a reflection. So my graph was flipped over the x-axis. All right, let's review a little bit. Okay, so number 1, it says graph the function and its parent function, then describe the transformation. If you're using Desmos, you can put in the parent function and then the new function and look at it graphically, or you can use a graphing calculator, or we can make a table. So I have -2, -1, 0, 1, 2. If I plug that into my parent function, y equals x, I'm gonna get -2, -1, 0, 1, 2. If I plug it into x plus 3, -2 plus 3 is 1, -1 plus 3 is 2, 0 plus 3 is 3, 1 plus 3 is 4, 2 plus 3 is 5. So if I was just sketching a little graph here, I have -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. So there's our parent function, y equals x. And then here I have, now I have -2, +1, -1, +2, 0, 3, 1, 4. And as you can see, I have simply shifted or translated my graph up 3. So basically what we did is we added 3 to all of our outputs, our y values, which shifted our graph up 3. Or you can think of it as we changed our y-intercept from a 0 to a 3. So translation up 3 units. Okay, number 2 is a little more complicated. It looks quadratic, so I know I have my y equals x squared is my parent function. So I know that looks like my U shape. All right, where we have 1, negative 1, 1, 1, 1, 2, 4, negative 2, 4, and 0, 0. All right, I'm gonna change my x values a little bit because I know it's coming. I'm just gonna use a 1, a 2, a 3, and a 4. All right, so if I substitute a 1 in here, what is 1 minus 2? Negative 1. What's negative 1 squared? Positive 1. If I plug a 2 in there, 2 minus 2 is 0, and 0 squared is 0. So 2, 0 is gonna be on our graph. 3 minus 2 is 1, and 1 squared is 1, and I'm already seeing that symmetry of my U shape. 4 minus 2 is 2, and 2 squared is 4. So let's plot those. 1, 1 is here, 2, 0, 3, 1, 4, 4. So here's what's happening. My parabola got translation right 3 units. So when you're adding and subtracting on the, right 2 units. When you're adding and subtracting something on the inside of the function, it goes the opposite direction. So we minus 2 on the inside, it moved right 2. But again, you can look at it on a graphing calculator at this point, or Desmos, and just describe the transformation. We'll talk a lot more about these to come. All right, lastly, I have this negative in front, and I remember that as a reflection or a flip. So if you know the parent function, y is equal to the absolute value of x, is our simple V shape. If we take the opposite of that, it's gonna take my graph and flip it over the x-axis. All right.